Welcome to the Deep Dive. If you coach or train athletes in team sports like soccer, basketball, rugby, well, you know the small-sided game, the SSG, it's absolutely vital, right? A core part of pretty much every training week.
Yeah, it really is. It's that perfect blend, isn't it? Where you get the specific tactics of the game mixed right in with some really high-intensity physical work.
But here's the thing, the challenge that I think keeps every sports scientist, every coach sort of awake at night.
Yeah.
How do you actually program these SSGs? How do you push for that intensity, get the tactical benefit, but without causing this deep, lingering fatigue?
Exactly. That residual fatigue that might just sabotage the next session, or worse, bump up the injury risk. We all know they're intense drills, that's obvious. But the science around the recovery, well, that's often where the real mystery lies.
Absolutely. And, the traditional approach often assumes, well, if the heart rate's down, if the players say they feel okay, they're good to go.
Right. Stop complaining, get back out there.
Yeah, but what if there's internal damage still lingering? Stuff you just can't see. To figure that out, we decided to dive into a really comprehensive piece of research that pulls everything together.
Yeah, our mission today is basically to unpack this scoping review. The full title is Acute and Residual Physical Fatigue, along with recovery time following cited games, a scoping review and evidence gap map focusing on methodological aspects.
Yeah.
A bit of a mouthful.
Definitely.
It's by Filipe Manuel Clemente and 8 colleagues, published in the Journal of Sports Science and Medicine in 2025. And it really maps out what we currently know, what researchers are measuring, and importantly, where the big blind spots are in SSG research.
So their goal wasn't just like summarizing findings, it was more like building a master map, wasn't it?
Precisely. What tests are being used? How does the body respond across 3 key areas: neuromuscular, psychophysiological, and biochemical? And crucially, what are the evidence gaps we really need to fill?
And what's the big headline, the main takeaway?
Well, the main conclusion they hit you with right away kind of challenges a lot of the standard coaching timelines. Yes, SSGs definitely impose a high acute load, cardiovascularly speaking, but that residual fatigue, especially things related to muscle damage and strength loss, that can hang around not just for 24 hours, but often 48, sometimes even up to 72 hours.
Wow.
Yeah, and that timeline really, really depends heavily on the specific format of the game you choose to run.
Okay, that 72-hour window, that kind of flips traditional planning on its head, doesn't it?
Yeah.
If you're potentially causing that level of damage with a standard drill, what are coaches typically getting wrong when they slot SSGs into the middle of the week?
Well, they might just be underestimating the mechanical toll. SSGs are so popular for good reason, right?
Yeah.
They mix technical and tactical aims with physical conditioning. They try to replicate that dynamic chaos of a real match.
That specificity.
That specificity is absolutely key.
And that specificity, especially in tight spaces, it drives the intensity up, right?
Mm-hmm. It really does. The smaller pitch, fewer players, it just massively increases how often each player has to perform a technical action. More passes, more shots, more turns, more decisions. Physiologically, SSGs consistently push athletes hard.
Mm-hmm.
We see high heart rates, typically sustained around 85 to 90% of max HR. And actually, some studies even show blood lactate levels that are higher than what you'd see in a formal match.
Wait a second. If the space is smaller, players aren't covering those huge distances like in a full game.
Yeah.
So why would the physiological load sometimes be higher?
That's a great question. The source material clarifies this distinction. While you're right, the high-speed running distance is usually lower in SSGs because there's just not enough space.
Right.
They impose significantly greater demands on acceleration and deceleration, those constant start-stop change direction movements in a confined area.
Yeah, the AD actions.
Exactly, the AD actions. It's those repeated changes in momentum that drive up the localized physiological and metabolic cost. It taxes different muscle groups and in a different way than just sustained running in a straight line.
Okay, that makes sense. Now, shifting to the evidence itself. This scoping review included something called an evidence gap map. Just looking at that map, you said it immediately shows a major limitation.
Oh, absolutely. It paints a picture of a very, very narrow lens. The evidence base is heavily skewed, which really limits how much we can generalize from it.
How so?
We're talking, 30 out of the 33 samples they looked at focused exclusively on highly trained, so-called Tier 3 male soccer players.
30 out of 33.
Yeah. So if you're coaching women or youth players or athletes in other sports like basketball, handball, rugby, let alone adaptive athletes in wheelchair basketball, for example, this huge body of research, it only gives you a tiny, tiny fraction of the relevant picture.
And even within that male soccer player research, the specific game formats they studied are pretty concentrated too, aren't they?
Very much so. The research is heavily clustered around the smallest formats. 4v4 was in 20 studies, 3v3 in 10 studies.
Okay.
But the larger formats, maybe 6v6, 7v7, 8v8, which you might think are potentially more taxing in different ways, surprisingly underrepresented. And across all these skewed studies, the most common things researchers actually measured were psychophysiological, basically heart rate, and how hard the players felt they were working, their RPE.
All right, let's dig into the specifics of that fatigue now, starting with the physical side. Domain 1, neuromuscular responses. So strength, explosiveness. What measures were researchers typically using here?
They mostly relied on tests that are easy to do out on the field, things like short sprint times, maybe 5 to 30 meters, assessing vertical jump height using the counter movement jump, the CMJ.
The classic CMJ.
The classic CMJ, yeah. And sometimes more specialized strength tests like measuring hamstring and quadriceps strength using maximal voluntary isometric contraction, or MVIC.
Okay. Now, what did they find about immediate impairment? Does every SSG just tank performance right away?
Well, no, not universally. And this is actually where the CMJ shows maybe some limitations as a marker. Reductions in jump height or sprint speed are common, but they aren't guaranteed after every single SSG.
Interesting.
For instance, there were studies cited, like Clemente L. back in 2017, where some pretty intense 1v1 and 3v3 drills caused high RPE, high heart rate, but they didn't actually impair CMJ or squat jump performance right after.
Wow.
So it kind of suggests that maybe CMJ isn't always the most sensitive tool for picking up certain types of fatigue, especially immediately post-exercise.
Okay, so this is where we separate the good coaches from the great ones, right? What were the clearest signs of that lingering residual fatigue, the stuff that really sticks around?
Right. The key markers that emerged seem to be sprint capacity, specifically acceleration ability over short distances, and knee flexor strength. Hamstring strength, basically.
The hamstrings. Always the hamstrings.
They're always the hamstrings. And the evidence seems pretty strong that the size and the density of the game format directly influences how long this impairment lasts.
Okay, can you give us a concrete example of that format difference?
Sure. There was one key study, Papanikolaou et al., 2021. They found that larger format 8v8 games produce longer-lasting drops in CMJ and sprint performance compared to a 4v4 format, and that fatigue window was pushed out to 48, maybe even 72 hours.
Wow.
And another one, Madison et al., 2019, showed that if you played a 4v4 over a larger area compared to a really tight 3v3, the 4v4 caused greater drops in hamstring isometric strength after the session. So it seems the mechanical demand, not just the pure metabolic intensity, is a huge driver here.
So the key variable isn't just duration or intensity, it's that mechanical loading.
Yeah.
Can we define what makes something mechanically challenging in this context a bit more?
Yeah, it's really about the sheer volume of high-force eccentric contractions. Think about all the braking forces when you decelerate or change direction rapidly.
Right, the stopping and starting.
Exactly. And this gets amplified significantly if you add contact. The review mentioned a study on rugby league 6v6 drills, Johnston et al., 2014. Adding contact led to much bigger power losses in both the upper and lower body, and that loss persisted for a full 24 hours.
Okay.
So the main message here for you, the listener, is probably that hamstring strength and acceleration ability seem to be better indicators of that deep, longer-lasting fatigue than maybe just relying on CMJ alone.
Got it. Okay, let's move to domain 2. Psychophysiological responses. This is about internal strain and how the players actually feel. We know the heart rate's high. What about their perception and maybe what their autonomic nervous system tells us?
Yeah, the cardiovascular load is undeniable. Like we said, HR consistently near 90% max. Autonomic measures, things like heart rate variability or HRV, they typically show an acute drop in parasympathetic activity right after the SSG.
Meaning they're stressed, fight or flight.
Exactly. The body's in a high-stress state. But the good news, generally, is that this autonomic function tends to bounce back pretty quickly, usually normalizing within 24 hours.
Okay, 24 hours for the nervous system. What about the good old rating of perceived exertion, RPE? That's what most coaches rely on day to day, isn't it?
It is, and this is where we hit the RPE paradox, as the review calls it.
Right.
There was one really fascinating study, that same Papanikolaou one, comparing 4v4 and 8v8. They found that even though the 4v4 drill elicited higher heart rates and higher blood lactate levels, meaning physiologically, it was objectively harder.
Right.
The player's rating of perceived exertion, the RPE, was actually higher in the 8v8 format.
Oh, okay. That's a critical difference. If the 8v8 is objectively less taxing cardiovascularly, why would the athletes feel like they worked harder?
Well, it strongly suggests that things like tactical demands, the cognitive load of the game, and maybe the density of players in the space, these factors shape how effort is perceived beyond just the raw physiological output.
So more decisions, more scanning.
Exactly. The larger 8v8 game likely forces more complex decision-making, greater spatial awareness, maybe a higher organizational burden for the players. You know, any coach watching knows that feeling players might be walking, but they look mentally fried because they're burning mental calories, not just physical ones.
Yeah, absolutely.
So RPE seems to reflect that total burden, which includes the cognitive and tactical strain, not just heart rate or lactate.
That's vital context. So RPE can be high, but maybe for the wrong reason if you're only thinking about muscle fatigue. What about the simplest perception marker, though? Just soreness, DOMS.
Delayed onset muscle soreness. That seems to be stickier than the autonomic fatigue. The review found it was consistently still elevated 24 hours after both small and large format SSGs. So even if your HRV looks okay and the immediate mental stress is gone, the muscles themselves are still letting you know about it.
Right, still sore. Okay, finally, let's hit domain 3. Biochemical and endocrine responses. These are the deeper internal markers, metabolic stress, actual muscle damage.
Yeah, and here we really need to distinguish between the immediate metabolic stress markers and the delayed indicators of structural damage.
Okay.
Things like blood lactate, acid-base balance changes. They map that immediate metabolic stress pretty well, but they tend to resolve quite quickly, often within the hour post-exercise.
Right.
But the really critical finding here relates to the delayed damage marker, creatine kinase, or CK.
Just CK. That's the classic indicator of muscle cell breakdown, correct?
Precisely. And CK follows a very different delayed timeline compared to lactate. It often doesn't even peak until 24 hours after the SSG.
24 hours later.
Yeah, and it can stay elevated for 48, sometimes even up to 72 hours, especially after those higher density or mechanically demanding formats, like the 4v4 compared to 8v8 in that Papanikolaou study again. This biochemical finding lines up perfectly with that lingering neuromuscular fatigue, particularly the hamstring weakness we discussed earlier.
Okay, and this is where we really connect the dots for the listener, right? If CK is peaking at 24 hours, still high at 72, and hamstring strength is also impaired for maybe 72 hours, what's the practical implication there for injury risk?
The implication is potentially massive. That prolonged impairment in muscle strength, especially in those crucial knee flexors, the hamstrings, happening at the same time as biochemical evidence shows significant muscle damage. It means the athlete is likely operating in a state of heightened injury susceptibility.
Especially for certain types of injuries.
Especially if they're asked to perform high-speed running, sprinting, or highly explosive actions on day 2 or day 3 after that tough SSG session. This is why really careful programming and monitoring become absolutely essential.
Makes perfect sense. What about hormonal responses? Do they find SSGs cause major hormonal shifts that might signal overtraining risk?
The hormonal changes seem generally more short to mid-lived. Testosterone often shows a quick, temporary rise right after, followed by a slight suppression that might last anywhere from 2 to 24 hours. Cortisol, the stress hormone, tends to return to baseline pretty quickly, often by 24 hours.
But it varies.
It does vary quite a bit, yeah. Findings differ significantly depending on the sport, the specific protocol, and even the time of day. For example, one study they cited, Beato et al. 2020, found that doing a 4v4 session in the evening actually induced a pretty robust surge in salivary cortisol. So timing matters for the endocrine system too.
Okay, so we've established the potential for damage and the timelines. Does the review offer any insights into actual recovery interventions, things coaches can do?
It does touch on that, yes. Looking specifically at post-match recovery strategies, one comparison highlighted that using active recovery, like a low-intensity cycle, was actually superior to doing a recovery session that included more soccer-specific training, which involved more SSGs.
So doing more SSGs isn't recovery?
Exactly. The active recovery was better at restoring hamstring force and reducing those elevated CK levels by 72 hours post-match. So the powerful takeaway there is if you're putting more SSGs or intense specific drills into what you're calling a recovery session, you're likely just prolonging that muscle damage window unnecessarily.
Okay. So after pulling together all this data, synthesizing everything, what does this big scoping review conclude about the current state of SSG research? Where are our major blind spots?
Well, we kind of circle right back to those core limitations we mentioned earlier. The huge variety in methods used, the methodological heterogeneity, and the really narrow scope of the population studied.
Right, the male soccer player bias.
Overwhelmingly skewed towards highly trained Tier 3 male soccer players. Again, if you're coaching women's basketball or youth rugby or recreational athletes, this massive research base, it might only give you like 2% of the picture you actually need.
And even within soccer, trying to compare findings from a tiny 1v1 drill to a big 8v8 game must be almost impossible, right? Apples and oranges.
It creates a tremendous problem for comparison, yeah. The sheer variety in formats, the different work-to-rest ratios people use, the different pitch sizes, it makes drawing firm conclusions across studies incredibly difficult. And compounding that, a really significant number of studies didn't adequately report or control for the concurrent training load.
Meaning what else the athletes were doing.
Exactly. They didn't properly isolate the SSG session from everything else the athletes did that day or week. So it's hard to definitively say that the fatigue observed was solely due to that one SSG session.
Okay, that's a big confounder. And you mentioned a gap in the timeline data as well.
Yes, absolutely. If you look at when measurements are taken, assessments are heavily concentrated immediately post-SSG and then again at the 24-hour mark.
But not much beyond that.
Surprisingly few studies actually extended their monitoring past 48 hours, so we don't always get the full picture of the recovery trajectory, especially for those slower recovering markers like muscle damage, CK, and specific strength measures. We see the peak damage often, but not necessarily the full return to baseline.
Right. So given all these gaps, the population bias, the methodological messiness, the short timelines, what are the clear directives for future research? What needs to happen next?
The authors laid out pretty clearly future studies really must broaden the populations they study. We desperately need more research on female athletes, youth athletes, athletes in other sports, and adaptive athletes.
Okay.
We also need greater methodological consistency. Researchers need to try and standardize things like work-to-rest ratios, how load is reported, maybe even pitch dimensions relative to the number of players to allow for better comparisons.
Makes sense.
And furthermore, we need more studies that integrate multidimensional outcomes. So don't just measure CMJ and RPE, maybe add cognitive function tests, look at different biochemical markers simultaneously, and crucially, extend that follow-up window out to 48, 72, maybe even 96 hours to truly capture the full recovery curve.
Okay, so wrapping this up. The main message that you, the listener, need to walk away with is this. Yes, SSGs deliver that high cardiovascular and metabolic load we want. But while the perception of fatigue, the RPE, and maybe autonomic recovery like HRV might bounce back relatively quickly.
One within 24 hours.
Right. But the harder physiological markers, the evidence of actual muscle damage like creatine kinase and the associated loss in specific strength, especially hamstrings, that stuff often persists for 48 to 72 hours. And that demands really careful programming, doesn't it? Especially if you're using high-density formats or adding contact.
It really does. And this raises, I think, a really important question for you, the coach, or the learner listening to this. If your go-to markers, like global RPE, often recover quickly, or if a common field test like the CMJ can give you inconsistent results about fatigue, how can you implement SSGs strategically and safely? Especially if your most accessible markers might actually be under-detecting significant residual muscle damage and that critical hamstring weakness. The evidence we've discussed today really suggests that relying on just one marker isn't enough. You need a more multidimensional assessment approach and probably need to be more proactive and cautious with rest and recovery periods than maybe tradition dictates to truly optimize performance and keep your athletes safe.
That is a really compelling thought to mull over before planning your next training block. If you want to dive deeper into the specific studies, the methods, the detailed data tables we talked about today, definitely find the full article. Again, it's acute and residual physical fatigue, along with recovery time following cited games. A scoping review and evidence gap map focusing on methodological aspects.
Published in the Journal of Sports Science and Medicine, 2025, DOI 10.52082 JSM.2035.779 by Filipe, Manuel, Clemente, and colleagues.
Thank you so much for joining us for this deep dive. If you found this analysis useful, please be sure to follow our channel and turn on notifications so you don't miss future episodes like this.